For Management, Central University of Jharkhand, Ranchi. Along with me is scholar Mr. Bashir Ahmad KK, a research scholar from Center for Land Resource Management. My topic, as you can see, it is geo-hydrological investigation using vertical electrical sounding at the Chinamushidiwada village in Vishakhapatnam, Andhra Pradesh. This is my study area. It falls in 17 degrees 47 minutes to 17 degrees 48 minutes latitude and 83 degrees 11 minutes longitude to 83 degrees 14 minutes eastern longitude. And the study area is a small micro watershed of 9.18 square kilometers. It is mainly drained by three major tanks. It's not so visible here, but there are three major tanks. The one on the top is Sujata Nagar, having tank bed area of 5 hectares. The other in between, in the middle, is Chinamushidiwada. It has 8 hectares. The last one at the bottom is Lakshmipuram tank, having 20 hectares. It's a medium irrigation tank. Almost it irrigates 500 acres per year. And these are the 3 tanks which are providing drinking water source to the local inhabitants. And the whole study area has been thoroughly surveyed using total station survey. And these tanks are to be protected at any cost and to be converted into urban storage tanks to meet the growing demands in that area. And this is the topo sheet of that study area, whose number is 65 O/1, Survey of India 1:25,000 is the scale. They are the tank boundaries having catchments. Each tank has a catchment. This is contour map of the study area, slope map of the study area, slope from east to west. Land is land cover of the study area, hydrogeomorphology map, and these are the objectives. My objective is to delineate subsurface stratigraphy for aquifer delineation and their extent. How much is the aquifer present below, at what extent it is extending, how far can we recharge, and identifying the groundwater recharge zones and intrabasin transfer technique is one such technique where we can transfer water from a catchment having more potential storage capabilities to the less potential areas. And this is the overall methodology followed in the work, but this paper talks only about geophysical investigation, which I clearly represented as vertical electrical sounding. That we will talk now. This is the methodology for geotechnical investigation followed. Typically, an electrical current is applied to the ground through a pair of electrodes. A second pair of electrodes is then used to measure the potential difference, voltage, and the greater the distance, the deeper the investigation is. And this is a Schlumberger array followed. The equation is mentioned. Mn is the distance between the potential electrodes, and Ab is the distance between the current electrodes. And this is a study area where we have taken 30 VS locations. Data has been collected at 30 locations, and this is the data at every location given in tabular form. 100 meters is the total separable distance between the electrodes. And then second, there is a field curves drawn using IPI2 software, and on the x-axis we have distance between the electrodes, and on the y-axis we have apparent resistivity measured in ohms.
Actually having AB by 2, half of that.
Yes.
Half of that.
Yes. And this is quantitative interpretation showing geoelectric parameters. And the one highlighted in red are the validation points collected in the field by digging bore wells. And the curves mostly were H-type curves having low resistivity value for the second thickness layer. And these are the soils lithological units assigned as per the resistance we received. And these are around 30 locations. And the one highlighted on red is the borewell points collected. These are the locations of 30. And we have already drawn profiles across the study area. Profile AA dash, profile BB dash, CC dash, DD dash. And this is the blue color indicates the groundwater potential zones. Red indicates high apparent resistivity, mostly hills and hard rock terrains. And this is the isopac map generated for the study area. Isopac are the lines joining equal points of thicknesses. And at the southwest central part, you can notice dark blue color is the deepest aquifer present, extending from 60 meters to 80 meters in thickness. And this is the field photographs mentioned. Charnockite and Condylite are the quarrying pits available next to our study area. And these are the where borewells were dug. Lakshmipuram, Uda Colony, Drivers Colony, Sujata Nagar, having soil profile like something like this. And it was done for Uda, done for some scheme, government scheme, done for a domestic house owner, Mr. Nokaraju, and the other at a colony called BHPV, Sujata Nagar. And these are the lithological units were identified. These are the field photographs where we have dug samples to validate our results. And these are the pollution we noticed. People throwing sewage, sewage into those nearby tanks. So it is high time for us to protect these tanks from pollution, from urban encroachments as well. Those occupations observed in and around the tank bed areas. And this is the summary and conclusion. Hard rock is spread directly below the soil. 5 meter is the minimum layer thickness soil available in the area. And we have come up with a good recharge structure which can go deep into 5 meters to recharge whole of your rainwater, storm water, rooftop, harvested water, whatever, directly into the aquifer, so that it can be recharged, and it can also be recharged from the nearby catchment areas as well. The geophysical studies reveal that deeper aquifers are present somewhere west part of the study area where aquifer zone extending 80 meters, as I said. And this is the best recharge structure we have suggested. We can even take water from one catchment to the other catchment through subsurface pipes. Everything dimension has been fixed as well. 6 inches is the diameter we suggested. And each water body should be deepened to a minimum of 3 meters depth to accommodate more storage, and can be converted into urban storage tanks as early as possible to avoid problems of acquisition rehabilitation costs. Thank you. Just to cover in time.
Thank you. What resistance value you get when you find the aquifer? Like you interpret that this resistance or resistivity, so this is the aquifer. So what resistance value you get for aquifer? Generally for interpretation.
Resistance value you are talking about.
Resistance value. In
the 100 to 200.
It might constantly at one distance, so that your voice is broken.
I want to know what resistance value you get, then you interpret it as an aquifer.
Okay, aquifer has weathered zones, hard fractured zones as well. But hard rock is something where the aquifer ends. So when you reach the hard rock, the apparent resistivity always shows some infinite values, very high values. So we have got around 1500, below 2000 is a value we can consider it as an aquifer, having hard fractured zone till that thickness.
So you take the reading till you get the hard rock.
Yes, of course.
Thank you.
Your information for the author and for you. Geological formation is having a resistivity value in the range of 30 to 50 ohm meter. It is not fracture formation. Then it is considered water bearing. Fracture, for the fracture it is 120 to 200 ohm meter, and beyond this one it is a totally water divide formation. And these values, again I will telling you, these values are available on the website of the Central Groundwater Board. For every geological formation they have given the information how you can correlate the resistivity value with the geological formation. So please, without giving their own interpretation, it is better you take the value from the Central Groundwater Board website, and that is a standardized value, and interpret your result with this one. And another suggestion is that if you can afford or you can, because you know that this vertical electrical sounding with 4 electrodes, they give the only target value which is falling below the center of your this electrode.
Yes.
If your target is away from the center, you cannot detect it.
Yes, sir.
And every time you have to change the electrode to increase the depth of penetration.
Yes, sir.
So it is better to go for the 2D by electrical tomography, electrical resistive tomography. Of course, the instrument is very costly, 30
Yes,
to
sir.
40 lakh rupees.
Yes, sir.
But it will give you, you have to not change the electrode. One time you lay down your electrode and you get the 2D pictures, and very clearly you can get the fracture zones, hard rock. So this is a very useful tool.
Thank you very much for your valuable suggestion, sir. Since you are from NGRI, you are very much familiar with geo-resistivity survey. I understand. As you said, DDR3 model was used as the resistivity meter in my study, but we can even go with GPR, ground penetrating radar, which is very costly, which I cannot afford in my university as of now, but we have
It is
plans
not
to-
GPR, the electrical GPR is different.
Different, yes.
Ground penetrating
But
radar.
more advanced.
It is not more advanced, depth of penetration only 50 meters. It is more useful for the municipal work, not for the groundwater exploration.
Okay.
If you want to identify where is the pipe leakage is there or some spillage is there, so there GPR is useful. But a groundwater electrical electricity tomography, you can go up to 200 meters.
200 meters, okay. Thank you very much. And next time we will make sure that to go ahead with
Yeah,
your
okay.
instrument.
So now we will move to the next.
Thank you very much, sir.